everyone, today we will discuss Vensim and demonstrate it with other members so that you can better understand how to use it in our future work. So before we begin, I'm Joanna Rosnalda together with Mr. Pitaliana, Mrs. Pares, Miss Rigahal, and Miss Rosales. Let us define first what is Vensim. So Vensim is a visual modeling tool that allows you to conceptualize, document, simulate, analyze, and optimize models of dynamic systems. Vensim provides a simple and flexible way of building simulation models from casual loop or stack and flow diagrams. So Vensim is a powerful visual tool that helps people understand and predict how complex systems work. It's like a smart simulator that breaks down complicated processes into easier to understand parts. So this tool is valuable because it allows users to model real-world scenarios, test different situations, and see how changes might impact in or an entire system. Next is the five key functions of Vensim. First is the model building, simulation, data input and calibration. Fourth is the sensitivity analysis. And lastly is the causal loop diagram. So let's go first to the model building. Model building in Vensim allows users to construct models that represent the dynamics of systems. Users can define relationships, variables, and feedback loops to simulate the interactions within a system. Models are built using stacks or the accumulations or resources, flows or the rates of change, and variables that link different parts of the systems. So these functions is like creating a detailed map of a system. Users can draw out how different parts of a system connect and influence each other. Imagine building a model of a business where you can see how inventory, sales, and customer demand are linked. By using stacks, the resources, flows, or the changes and the variables, users can create a complete picture of how a system might work. Second is the simulation. Once a model is built, Vensim allows for time-based simulations to understand how a system evolves. Users can adjust time intervals and simulate how the model behaves under different conditions. Support deterministic and stochastic or the randomized simulations, allowing for the testing of uncertainties and variability within a system. So, simulation, think of this as a time machine for systems. Once you've built your model, Vensim lets you play out different scenarios over time. You can adjust time periods and see how your system might change under different conditions. It's like being able to test multiple what if scenarios within real world risks. So the tool supports both predictable and random simulations, which means you can explore various potential outcomes. Third key functions of Vensim is the data import and calibration. So Vensim enables users to import real-world data, calibrate models, and test the accuracy of simulations. By fitting models to historical data, users can ensure that their models realistically represent real-world systems. So this function is like a fact checker for your models. Vensim allows users to bring in real-world data and adjust their models to match historical information. It's similar to tuning an instrument to make sure to place the right notes. By comparing the model to actual past data, users can make sure their simulations are as accurate and realistic as possible. Fourth is the sensitivity analysis. Vensim has built-in sensitivity analysis tools which allow users to test how changes in specific variables impact the overall model. This helps identify critical factors and parameters that drive system behavior. So this is essentially a stress test for your model. Vensim helps users understand how small changes in one part of a system might cause big changes overall. This function helps identify which factors are most important in driving system behavior. The last key functions of Vensim is the causal loop diagram. Vensim allows users to create causal loop diagrams which visually represent feedback loops within a system. Positive and negative feedback loops are displayed, helping users to understand reinforcing or balancing processes in the model. So these are the visual storytellers of systems interactions. Vensim creates diagrams that show how different parts of a system influence each other, using positive and negative feedback loops. It's like drawing a map that shows how actions can create chain reactions within a system, helping users understand complex relationships at a glance. Next will be the purpose of Vensim, which will be discussed by Ms. Ispares.
I'm Christine Perez, and next is the purpose of Vensim. So the primary purpose of Vensim is to model, analyze, and simulate complex systems using system dynamics. It is widely used to understand how systems behave over time, explore feedback loops, and test the impact of different decisions or policies. Vensim is particularly useful in the fields like business, engineering, healthcare, economics, and environmental science. So first is understanding system behavior. So Vensim provides an insights into how various parts of a system interact and influence each other. This helps users understand the underlying factors that drive system performance and identify key leverage points. So meaning, Vensim helps you see how different parts of a system work together and change over time, like understanding how supply and demand affect a business. So second is policy design and analysis. So in the fields like public policy, healthcare, and business, Vensim helps evaluate the impact of different policies before implementation. By simulating outcomes, decision makers can test strategies and predict their effects over time. So, Vensim is software where you can use it to test ideas or rules before applying them, such as figuring out how changing a budget might affect outcomes. So third is problem solving and strategic planning. So Vensim aids in identifying and solving complex problems within a system by mapping out the relationship and dependencies. This makes it an effective tool for strategic planning, allowing organizations to visualize long-term impacts and optimize processes. So Vensim can help identify issues in a system and plan solutions, like finding out why a project is delayed and creating a better solution or a better schedule. Fourth is training and education. Vensim is widely used in educational settings to teach system dynamics and modeling principles. It offers an accessible way for students and professionals to build and analyze model which strengthens their understanding of dynamic system. So Vensim is great for learning about how system works and teaching others, making it useful for students and professionals who wants to understand complex topics more easily. So Vensim application can be in supply chain management, so by simulating inventory flows, demand forecasting, and identifying bottlenecks in the supply chain. Next is environmental modeling. So by predicting the impact of pollutants or conservation strategies on ecosystem. Next is to healthcare systems. By analyzing patient flow, resource allocation, or the impact of health policies on population health. And lastly, for business strategy, by assessing market dynamics, product lifecycle management, and the pricing strategies.
Now, before we proceed to the actual demo of using Vensim, let us first familiarize ourselves with every icon you will encounter in the application. This will help us better understand each function and enable us to use Vensim more efficiently and smoothly. Now, before we proceed to the actual demo of using Vensim, let us first familiarize ourselves with every icon you will encounter in the application. This will help us better understand each function and enable us to use Vensim more efficiently and smoothly. Now, before we proceed to the actual demo of using Vensim, let us first familiarize ourselves with every icon you will encounter in the application. This will help us better understand each function and enable us to use Vensim more efficiently and smoothly. Now let's start discussing the main toolbar. So first, the new model button. This helps us create a Vensim model. The open model button opens an existing Vensim model. The save button saves the Vensim model under the current name, and the name can be changed using the save as option in the file menu. The print button prints the current selection in the build window or the entire sketch if there is no selection. A print options dialog will be displayed to make custom settings. A selection is made by dragging the mouse to select the rectangular area. The cut button cuts the current selection into the Windows clipboard. The copy button copies the current selection into the Windows clipboard. The paste button pastes the current contents in the Windows clipboard into the sketch. And the undo button undo the last action you performed, while the redo button redo the last action you performed. The Setup a Simulation button highlights the constants and lookups of the sketch in the build window. Clicking the highlighted name allows you to temporarily change it for only the simulation run. While the simulation to be made button is the selected dataset is shown in the box. To change this, click on the vertical bar to the right of the box. The Run Comment button uses this to add a comment to save the simulation, while the Run a Simulation button, if the dataset is shown in the box to the right of this button already exists, you will be asked if you want to overwrite it. The Automatically Simulate and Change or the Sim button, a visual sensitivity analysis simulation approach versus the change, compute, and review approach. The sensitivity to all button run the model in sensitivity to all mode, while the run reality check button allows the user to make statements thought to be used about a model for it to be useful, and provides a machinery to automatically test a model for conformance with those statements. The output windows or the show or circulate button makes the output windows visible. If they are visible, circulate the active output window. The control panel button shows the control panel. This is used to select the workbench variable, adjust the time axis for graphs, set the type of scaling for graphs, manage dataset, and manage custom graphs. The error panel shows the error panel, and the Project Explorer shows the Project Explorer panel. Now let's proceed to the sketch tools. First button is the lock sketch. When the sketch is locked, mover size pointer can select sketch objects with a workbench variable but cannot move sketch objects. Next is the mover size words and arrows or the pointer button. Moves sizes and selects sketch objects in the build window. Move an object by dragging it with the move or size pointer. Select an object by clicking on it with the move or size pointer. Select multiple objects by dragging across them with a move or size pointer. Add or subtract an object to or from the currently selected objects by shift-clicking on it. Next is the variable or auxiliary constant. This creates a variable that is constant, auxiliary, etc. in the build window. Click on the spot in the sketch where you want to insert the variable, and the box will open up for you to enter the name of the variable. To enter the name of the existing variable, click on it with Variable tool. To enter the variable into the sketch, press the Enter key and right-click on the variable name with the move or size pointer or variable tool to change the way the variable is displayed. Next button is the box variable level. Create variables with the box shapes in the build window used for levels or stocks. Works in similar manner to a variable tool, and the size of the box can be adjusted by dragging the box handle or the small circle with the movable size pointer tool. Next button is the lockup table, which creates a lockup table. And arrow button creates straight or curved arrows in the build window. Click on the origin variable and then move the arrow pointer to the destination variable and click again to create straight line arrow. Next button is the rate button. This creates rate or flow constructs in the build window consisting of perpendicular pipe sections above and, if necessary, sources or sinks clouds, as with the arrow tool. First, click on the origin table and then click on the destination table. If you make one of these clicks on the blank part of the sketch, then a cloud will be created for the appropriate origin or destination. You can make right-angle bends in the pipe by shift-clicking the blank parts of the sketch with the rate tool where you want the bends to appear. The formatting of the vault can be changed by right-clicking on it. Next button is the Add an Existing Variable. Add an existing variable to the sketch. The drop-down button on the right allows you to add the workbench variable. Next is the Shadow Variable button. It adds the existing model variable to the sketch in the build windows as shadows or ghost variable without adding its causes. The drop-down button on the right allows you to add the workbench variable. Next is the Merge Variables button. This allows you to merge two variables into one. Next is Input Output Objects button. Adds input sliders and output graphs and tables to the sketch. See the Vensim documentation for more details. And the Sketch Comment button. It adds comments and pictures to the sketch in the build window. Click where you wish to place the sketch comment and the dialog will open up for many options for the form of comment. Note that with the same types of comments, you may have difficulties accessing some models variables after you have created the comment because the comment is overlaid on the model variable. If this happens, push the comment to the background using the rightmost button of the status bar. Lastly, the Show Variable button. This promotes the hide level on the variable. Another is the Hide Variable button. So this button increases the hide level on the variable. Next is the Hide Variable button in a pencil type, and this hides the variable on the view levels. Another is the Delete button. This button deletes structures, variables, or comments from the sketch in the build window. Place the pointer to this tool on an object to be deleted and click the left mouse button. The Equation button creates and edits model equation using the equation editor. After the equation tool is selected, variables without equations will be highlighted in the build window. Click on the variable to start this equation editor for that variable. The Reference Mode button. See the Vensim documentation for further information, and the Appearance Tool button is used to change the appearance of variables on a sketch in font, shape, etc. And the Alignment Tools button can be used to align Zeiss object on the screen.
Good day everyone, I am Leika Birgahal and I'm going to discuss about the expanded explanation of the purpose and uses of each Vensim app icon, particularly in the left side icons and the bottom icons. So I'm gonna start in the left side icons. First is the causes screen. Its purpose is to display all variables and elements that influence a selected variable. Its uses is it helps identify input factors or driving forces behind a variable's behavior, making it easier to understand dependencies. Second is uses tree. Its purpose is to show how a specific variable is utilized in other parts of the model. Its uses is it is useful for tracing the impact of a variable on downstream elements and understanding its role in the system. Next is loops. Its purpose is to identify and highlight feedback loops involving the selected variable. Its uses is it allows analysis of reinforcing or balancing feedback, which is critical for understanding system dynamics. Next is document. Its purpose is to open documentation or notes attached to a particular variable. Its uses is it is useful for reviewing or editing additional information such as descriptions, assumptions, or metadata related to the variable. Next is document all. Its purpose is to generate documentation for all variables in the model. Its uses is to provide a comprehensive summary of the model, which can be used for reporting, sharing, or reviewing the model structure. Next is cause strip. Its purpose is to display a linear sequence of variables influencing a selected variable. Its uses is to offer a streamlined view of cause-effect chains, useful for focusing on specific causal relationships. Next is graph. Its purpose is to display a graphical representation of simulation results for selected variables. Its uses is to help visualize trends, patterns, and behaviors of variables over time for analysis and reporting. Next is table. Its purpose is to present simulation results in a numerical table format. Its uses is it is useful for detailed numerical analysis and comparisons, particularly for data validation. Next is table tear down. Its purpose is to break down stable data for a more granular view of results. Its uses is it allows in-depth examination of specific subsets of data to analyze finer details. Next is units check. Its purpose is to verify that all variables in the model have consistent and valid units. Its uses is it ensures model accuracy by identifying and resolving unit errors, which is critical for maintaining and logical consistency. Next is runs compare. Its purpose is to compare simulation results from multiple runs of the model. Its uses is it is useful for evaluating the impact of different scenarios, assumptions, or parameter changes on the model's outcomes. Next is sensitivity to all. Its purpose is it analyzes how changes in one variable affect all other variables in the model. Its uses is it helps identify critical variables that significantly influence the system, aiding in sensitivity analysis. And last, for the left side icon is view navigation. Its purpose is to allow switching between different views of the model. It uses model facilitates navigation in complex models that are divided into multiple views for clarity and organization. Let's go with the bottom side icons. First is rename current view. Its purpose is to rename the active view or diagram. Its uses it helps organize and label views to make them easily identifiable, especially in multi-view models. Next is view navigation. Its purpose moves between different views in the model. Its uses it allows quick access to various parts of the model for analysis or editing. Next is new view. Its purpose is to create a new diagram or workspace for a separate section of the model. Its uses is useful for dividing complex models into manageable parts or for experimenting with new ideas. Next is bottom toolbar. Its purpose is to toggle the visibility of the toolbar at the bottom of the interface. Its uses is to help customize the workspace by showing or hiding additional tools. Next is search views. Its purpose is to find and open views by their names, and its uses is it speeds up navigation in models with many views. Next to discuss is show or hide level. Its purpose is toggles the visibility of stock variables in the diagram. Its uses is it helps declutter the workspace by hiding unnecessary elements temporarily. Next is set fronts on selected views. Its purpose is to adjust the layering of elements in the view, and its uses is it ensures that important variables or elements are displayed on top for clarity. Outline color. Its purpose is to change the outline color of selected variables or components. Its uses is it enhances visual organization by categorizing elements with distinct colors. Next is set fill color on selected vars. Its purpose is to apply a fill color to selected variables. Its uses is it makes variables stand out for easier identification or classification. Second to the last is set polarity on selected arrows. Its purpose is it updates or adjusts the polarity, positive or negative influence of arrows in the diagram. And its uses is it helps accurately representing the nature of relationship between variables. Last is the hide level. Its purpose is to temporarily hide stock variables from the view. Its uses is it simplifies the diagram for better focus on flows or auxiliary variables.
So after we click the software, Vensim software, so this is um, the landing page. So first thing to do is we will click the file and new model, then click OK, then yes. So we have our new model, then save this model, save as, then file name, for example, Vensim, Vensim 2.0, save. Then the first one that we will be making a casual loop diagram, or also known as feedback loop diagram. So this diagram is valuable because this helps us to clarify our own mental models and make our thinking clearer. It identifies common archetypes that drive systems behavior and share our mental models and modify them with others, which potentially creates a rich dialogue. And this loop diagram consists of variables such as things, actions, or feelings that connect the causal links, or arrows with polarities, which are positive and negative signs, and delays listed as double yellow lines, and it indicate together these create a positive and negative feedback loops that describe the circles of the cause and effect. So let's break down the part so that we can see individual loops. So for example, we have our first variable here, which is the population. So the two things that cause the population to change is our births and of course the death rates. So arrows, so the arrow tools is used to represent these causal links, so we know that more birds increased the population, and fewer birds can decrease the population as well. And other factors being equal, we would say that the relationship of two variable has a positive polarity, or it is directly proportional. So this means that the two variables move in the same direction. More leads to more, or more birds leads to a more population or less births leads to a less population. So we indicate this that this causal relationship has a positive polarity by placing a uh, a plus sign next to the arrowhead. So we also know that more deaths lead to the decrease of population. So the variables are inversely proportional, which is uh, more leads to less. So more deaths leads to a less population, and less population leads to a more deaths. So we would say that this relationship has a positive polarity, and we represent this by labeling the arrowhead with a negative sign. So we have this a negative sign. So on their own, they don't tell us what's actually happening in the population. So di kita mo kung anong net population. So it is determined by whichever of these two relationship between the births and the population and deaths will grow, and whenever when deaths exceeds magtikada ko and deaths exceeds births, the population will shrink. Magtitikaguti yung population. Now, let's introduce some feedback into the model. So, feedback na natin model, which is the population, a greater more births leads to an increase in the population, and a population also leads to a more births, since more people make more babies given a birth rate of course, and birth rate is, if there is a increase in the birth rate, there's a decrease of birth, and decrease of birth rate, decrease in birth rate, there will be a decrease in births. So by considering so stays constant, remember we're only considering two variables that we are linking for polarity. Therefore, we draw a positive causal link from the population. So, from the population back to births. So, this links forms our first feedback loop. So, this is our first feedback loop that's shown in the left. So, this is our first feedback loop. What we call a set of relationship where one variable leads to a change in another variable that eventually leads to a change in original variable. So since increase or decrease and this loop. So to read this feedback loop, you can start with a variable and pick a direction. So let's read this one, starting with population, and more population leads to a more births, which leads to a more population. This called a reinforcing loop. So since it is more population, this is called a reinforcing loop. So we will add a comment here, reinforcing loop, or we just put R to represent reinforcing loop. because more births today leads to more births in the future, because births reinforce births. So similarly, and if you want to drag it down, if you want to adjust the size, close. If you want to delete unnecessary, here just click this tool, delete tool. Then births similarly less births would lead to a lower population, which would lead to a less births in the future. So, and this cycle is reinforcing process works in opposite direction as well. If there were the only feedback loop in the population system and the people did not die, then we would see a exponential growth. So if if we can see an exponential growth in the number of people, we have seen growth in the number of people. We have seen different types of feedback loop which examines deaths, and more deaths today leads to a fewer deaths. So so kanina is negative. So more deaths. So we examine more deaths. More deaths today leads to a fewer deaths in the future. Why? Because more deaths today will cause the population to fall. So this means that the less people will be around to die later. These types of loops is also known as balancing loops. So ang kanina is reinforcing loop, adin naman is opposite direction is the balancing loop. So click the comment tool, then B for balancing loops. Since it is opposite, we have counterclockwise, then close. And if you want to adjust the size, just click this circle and drag it down, and close. Then so since more leads to less, so more population can less more deaths lets the population, or more leads less to less, or less leads to more. So the original change is balance. So balance in the opposite direction. So these feedback loop are set of a relationship that are always happening over and over again, generating behavior that upholds over time. So these two feedback loops can cause few different behaviors, because based on birth rate and life expectancy tendency. life expectancy, we will observe that the population is increasingly the population is increasingly the population is increasingly as long as the reinforcing birth loop dominates and leveling off of the death loop balance is dominant. So as we can notice in this diagram that there are two we will add a delay mark in this casual loop since nilagay casual loop casual loop delay mark because these casual links between population and births and the population and deaths, this mark represent a delay in a situation. So this one represent a delay in situation where it makes or takes time before the effect plays out. So in this population example is takes time for an individual to become of age to have a child, which is why there is a delay between the population and the births, and delays is longer in some countries like for example New Zealand, where the average woman children age 29 years old compared to some developing countries like Philippines that the average woman has children at least than 20 years of age. So when creating a casual loop diagram, delays, these delays should be included, otherwise reader will assume that the effect will be immediate. So this one is the example of cash loop diagram. And if you want to copy this example, just highlight this one, then control C, or you can go to copy selection, then open Word file, Word file, then control V or paste. So we have here an example of casual loop diagram or feedback loop diagram. So that's all for casual loop diagram. So now let's proceed to stack flow diagram. So stack flow diagram, it identifies how the parts are connected and put some input basic math functions such as adding, subtracting, multiplying, and dividing case stacks or accumulations that are identified with the stacks that can go up or go down based on their flows of rates of change. So the advantage to moving from a stack flow diagram to a running model is that we can see what happened to the accumulations in the system over time. So the diagram isn't just a static pure of system, but rather it becomes dynamic like a moving machine or organism. So for example, first we will choose this stack tool. So since we're going to make a stack flow diagram. So first, for example, our stack is population of deer or deer. Population of deer. So so the number of deer are represented as the stock, so they can be born and add the population. So they can be born, so ang na-add ang population through have birth. Han deers. And by they can die by subtracting. So, kung ang population deaths. So, na-add ang population of deer because of birds and nag-iiba naman because of death. Then, so this the borns will depends on the two factors. So, how many deer and the birth rate. So, nako niya, and birth will depend on the birth rate of the deer. So, birth rate of the deer. So, the birth rate of the deer, or the percentage of the deer that will give birth in any given year, and how many die depends on two factors: how many deers and the average lifespan. So the deaths will depend on the lifespan of the deer. Then afterwards, after we make this diagram, since we will connect this diagram, so using this arrow tool. So the birth rate the birth will depends on the birth rate of the deer and the lifespan of the deer, so the death. So also the population of the deer will depends on the births of the deer, and the population will also depends on the deaths of the deer. So we have here our complete diagram. So to identify the change of rate of this population, we will add a functions or equations in this diagram. For example, as you can see, if we click this equation function, we will have this kind of features. So if we click population there, as you can see in this tab, we can see here a variable information, the information of our variable, the different variables in our given stack, the functions, the keypads, and variables that we need in our equation. So, for example, here are our total initial value for population of the deer is 200. So, if we want to check if our equation is correct, just click this check syntax. Then, as you can see here in the errors, the equation is okay. Then, click OK. So, then, may danan equation if unbox so ganyan niya. Then, we will click this also the birth of the rate. Then, for example, we will change the unit. So the birth of the rate will per year, which is for example 20% birth rate per year. Then click OK. And also the lifespan. So the lifespan will be mostly for example 10 years. So units is in years. Then click OK. So to get the total births of the deer, so we will just, as you can see here in the variable, we can see a birth rate and the population of the deer. So to get the total births, we will just multiply birth rate multiply by the total population of deer. So ito natin equation for in finding the value of the births. Then also the deaths will population of the deer divided by the total lifespan of the deer. So click OK. So here is the equation for this variable, and the units of course is per year. So click OK. So since we add to the equations to our diagram, we will try to run this diagram or model. So, kung magra-run hiya, ini ng mga functions is magagamitan. Like for example, we try to run this example. So, we just click here in the simulation tool here, So, run the simulation. So, do you want to yes. So, as you can see, nag-run ng aton diagram. Ang aton stock flow diagram. So as you can see in this graph, so this is the output of this diagram. If you can see here. So the time and the total deaths will depend on the like this. Then so these are the equations in our program or in our diagram. So the current death is 22, 20, 22, 24. Then so for example, if we less the lifespan of the deer, for example, and we have the same birth rate, as you can see, similar lagi hapon niya magiging output. So if we go beyond with the lifespan, magtitikada mo ang birth rate, magtitikaguti ang death rates o ang death of the deer. And if we going to less the birth rate into 0.2% per year, as you can see, magtitikada mo ang birth rate kaysa ang total birth, since ang population will go decrease, will decline. So if we also adjust the birth rate into 40%, as you can see, there's a huge increase in total births, and will add to the population. It will have a lesser deaths of the deer. So, and if you want to stop running of this program, just click this stop current sentence session button. So if you want to adjust the text font size, font style, so we will just here, then default, then click this one, then click italic, bold, or any kind font style, font size. So just click 40, 16, and italic, bold. So click OK. Okay. So as you can see, we change the this whole font size and font style of our diagrams. So that's all for stock flow diagram, and that's all.